In this lesson, I'm going to talk to you about how you can use the normal distribution to calculate probabilities. And there are two ways I'm going to show you how to do that. The first way is using the calculator. And we're going to use a function called normal CDF. And then the other method is using our statistical tables, specifically for the standard normal curve. Now, when you have a random variable and you know that that random variable is normally distributed, you can find the probability that x will lie on a certain interval by calculating the area under the normal curve on that interval. And we've been practicing that quite a bit so far using the empirical rule. So if you want to use the statistical tables to do this, what you're going to do is you're going to find the area under the normal curve by first converting your upper and lower bounds of that interval using z-scores. And then you're going to use the z-scores to look up on the table to find the area under the curve. Now, this is what it will look like on your table. The table will always give you the area under the graph to the left. So I would take whatever this value is here, x, I would translate it to our value of z, and then you look up on the table for your value of z, will give you the area under the curve to the left. Now, if you want to find the area to the right, because I know that the entire area under the curve is 100%, using the table, if I want to find the area to the right, I would just take 1 minus the area from the left. That is given in the table. So I'm going to walk you through some examples in this lesson on how to calculate these probabilities both ways, and then you can decide which way you like the best. So in this first example, this is an example to help us understand how the table works. So if I had a normal distribution and I have some value of x, I'll call it n, and I want to find the value of the probability below. So basically, I'm trying to find this area under the curve. That will give me the probability. So what you would have to do is you would have to take the value of n and translate it into your standard score, your z-score, and then you would look it up on your table, and the table would give you the area to the left, which is what we're looking for. So if we're given the area to the left, and we've got that this area is 0.0228, then we know that the probability that x is less than n is 0.0228. Now, if we add an additional part to that, we'll call this part A. If I want to find the probability that x is greater than n, then that's a different question, although we can use our answer from part A. If I want to see what's the probability that x is greater than n, now I'm looking for the area under the curve to the right. That's this purple area. I know that the area to the left is 0.0228 because the table would have given me that information. The table always, I can't stress this enough, the table will always give you area to the left of your value of z. So if you want to know the area to the right or greater than that value, then what you have to do is take 1 minus 0.0228 and find the complement, because we know the total area under the curve is 100% or 1. If I subtract off the area to the left, that will give me the area to the right. So that would give us 0.9772. So I would know that this area in purple is 0.9772. All right, in this example, I'm going to walk you through step by step on how to use the tables and the calculator for all of the parts in this question. And that way, by the end of this question, hopefully you'll have an idea of which method you like better, and you can just stick with that method. So another thing I want to point out before we get started, the methods that we're going to cover in this section can only be used for normal distributions. So you want to make sure that when you're using these tools that the values that are given to you are based on a normal distribution. So for example, if I asked you to hammer a nail into the wall, you wouldn't want to pick up a wrench. You'd want to pick up a hammer. So you want to make sure you're using the correct tool. So when you're using these tools, make sure that you're looking at a distribution that is normal. Okay, so in this example, it says the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. So our 63, which is our mean, is going to go in the center. And then each of these lines is going to represent 5, which is our standard deviation. So I have 63, and then I'm going to add 5 to get 68. Then I'm going to have a 73. Then I'm going to have a 78. And going in the other direction, we're going to have 58, 53, and then 48. All right, now we have an idea of what this looks like. Part A says, find the probability that a randomly selected student scores more than 65 on the exam. Now, I know that these are my raw scores. These are my X's. My Z's look like this for my standard normal distribution. So if I look at it in terms of my Z's, because that's what I have to use for the table, Z equals 0 corresponds to my X value, which is 63. Z equals 1 corresponds to my X value, 68. So I know if X is 65, that's what we're looking for, it's going to fall somewhere in here. So I know it's going to be between Z equals 0 and Z equals 1. Now it also tells us in the question that we want to find the probability that the student scores higher or more than a 65. So we are looking for this area that's shaded in purple, anything higher than a 65. So we have to first find our value of Z, and like I said, we know that it's going to be between 0 and 1. So I use my formula. So I use my X value is 65, my mean is 63, and I'm going to divide by 5. So I know my value of Z is 0.4, which makes sense because we knew based on our picture that it should be between 0 and 1. So now what we're going to do is we're going to look up Z equals 0.4 on our table. We're going to use, for these problems, we're going to use A and B. If you scroll down here, table A gives us our values of Z that are negative, and then table B gives us our positive values of Z. I also want to point out that if you look at the picture given in this table, that it shows you that the area to the left of Z is what's shaded. So that will give you a reminder that if you're looking for the area to the right, this table doesn't give you that information. It gives it to you from the left. So then you would have to subtract from 1 and find the complement if you're looking for that area to the right. Now, our value that we got for Z is positive. So I'm going to use table B, and our value of z was 0.4. So I'm going to come down and look for z is 0.4. And if you notice, that's right here where I highlighted 0.4. Now these values that are across the top will be if you go out an additional decimal place into the hundreds. So for example, if I got that my value of z was 0.45, I would start off with 0.4 here and I would come across, and this right here would give me my hundreds place. So I would look, if I had z is 0.45, I would use that value right there as the area under the curve on the left. Because our value of z came out to 0.4 exactly, I'm going to use that my hundreds place is 0. So I'm going to come across here, I'm going to see z is 0.4. So I'm going to find that my area under the curve to the left of z equals 0.4 is 0.6554. Now, because we have the area under the curve this way is 0.6554, and I want to know the area to the right, to find the probability that x is going to be greater than 65, I got to take 1 minus 0.6554, because that's the area in the purple. Now when I do that, I'm going to get 0.3446. Now using the calculator, we are going to use the function on our calculator called normal CDF. Let me show you how to use that now. To find the probability using the calculator, what we're going to do is we're first going to access the distribution list by clicking on the second button and then the vars button, and that way we're accessing that distribution list. Okay, now this is the same place we went to for binomial, PDF, and CDF. We're going to now choose normal CDF. I'm going to choose option number 2. I'm going to hit enter. Now, what we want to do is we want to enter in the lower and the upper limit of our interval. Since we want to find the probability of a student earning a score of 65 or higher, we want our lower limit to be 65 and our upper limit is going to be infinity. We want it to go from 65 and up. So I'm going to put in 65 here for our lower limit. For our upper limit, we don't have an infinity button on the calculator. It's not a number that we can just plug in. So what we're going to do is we're going to put in a super huge number. Okay, and the number that the calculator recognizes is 1 times 10 to the 99th power. That's scientific notation for a 1 with 99 zeros. So that's a super, super, super huge number. So I'm going to put in 1, and then I'm going to put in the E notation for the scientific notation. Now to access that E, you're going to use your comma button, and then it's the shift. You'll see that double E there. So you're going to hit second comma to access a double E, but it will come up as a single E. And then you're going to put 99. We want to go from 65 and all the way up to positive infinity. I'm going to put in that our mean is 63. Our standard deviation is 5. And then I'm going to hit enter on paste. It's going to bring us to the home screen. And then I hit enter. So there is my probability, 0.34457.83029. That's exactly what we got when we rounded to 4 decimal places when we use the table. When we round to 4 decimal places, we get 0.3446, and that's the same value we got using the tables. Now, if you have a different model calculator, where it comes up to the home screen like this, you want to use the same notation. You first put in your lower limit of the interval that you're looking at, then you put in your upper limit, and then you put in your mean and your standard deviation. You close parentheses and you hit enter. Okay, for part B, it says find the probability that a randomly selected student scores less than 85. So we have our normal curve. We need to figure out the value of z that corresponds to x is equal to 85 so we can look it up on our table. So to find z, I take my value of x, which is 85. I subtract the mean, which was 63, and then I divide by my standard deviation of 5. That is going to give me a z of 4.4. So if I look on our standard curve, 4.4 is way over here. Let me fix this. I feel like I made a big mess of that graph. So here's 0, 4.4 will be way over here. And we want to look to see what is the probability that someone is going to score less than 85. So we're looking for this probability here. Everything less than a z of 4.4. Now that's almost everything. There's just this tiny little spot here that's greater than 4.4, but that's almost the entire graph. So we expect this to be a huge percentage. The probability notation that we're going to use is the probability that x is less than 85. Now let's go ahead and use the table to actually calculate what that probability is. And it looks like the highest it goes is 3.4. And that's actually 3.49 if you look at the hundredths place up here. And that probability for 3.49 is 0.99998. So we don't have the specific value for 4.4 given the table. However, it is so close to 1 that if we round this to 4 places, it's going to end up being 1 anyways if we go past 3.4. Now the value that we're looking for is 4.4. Just looking at 3.4, it's almost 1. So if we go even further, then that is going to be even closer to 1. So for this, I would actually just round it to 1. So using the tables, we found that the probability is so close to 1 that we just rounded it to 1. Now, if we look at using our calculator function, we have our normal CDF, and what we're going to put in the parentheses, we got to put our lower limit, then we got to put our upper limit, then we got to put in our mean and our standard deviation. And when we hit enter, that will give us our probability of this happening. Now, for our lower limit, remember what we're looking at. Here's our x is 85. We want everything less than 85. So our interval is going to go from minus infinity up to 85. So 85 is going to be our upper limit. Minus infinity is going to be our lower limit. Now for infinity on the calculator, remember we always use 1e99 for that really big number. If it's negative infinity, we use the same thing, but we just put a negative in front of that one. So that's a really big number, but in the negative direction. So for our notation for the calculator, I'm going to put in negative 1e99. Then I'm going to put in our upper limit is 85. Then I'm going to put in our mean is 63 and our standard deviation is 5. So let's go ahead and do that on the calculator now. The bars button to access the distribution list, we're going to access option number 2. Since our lower limit in this case is negative infinity, we want to go all the way to the left. So we're going to do negative 1e99. Our upper limit is 85. We want to look for everything less than 85. That's our probability we're looking for. And then our mean is 63 and our standard deviation is 5. I'm going to hit enter. And it gives us a number that is so close that when we round it to 4 places, we get 1. Now, in the last 2 parts of this example, we're asked to find the percentiles. Now, in the previous sections, when we were asked to find a percentile, there was a formula that we used. However, in that instance, when we were using those formulas, we knew what the specific data values were. In this case, we know that it's a normal distribution, and we also know what the standard deviation and the mean values are, but we don't know what the individual data values are. And when we use those formulas, we need to know that so we can count to the correct position. So we can't use that method here. However, we can use, there's 2 methods here. We can use the table and work backwards, or on the calculator, what we can do is use a function called inverse norm. So first I'm going to show you the method using the table. So to do that, I need you to visualize what's going on here. Here's our normal curve. The question is asking us to find the 90th percentile. So what that means is we're trying to find the value of x where the cutoff is so that 90% is to the left and 10% is to the right. And remember what values in the table represent. The values in the table give us z values with their corresponding percentiles. So we're going to work backwards here, where we're going to look through the table and find the corresponding value of z that matches a percentile of 90%. I can narrow it down to finding a positive value of z because I know I'm on the right-hand side of my normal curve. And I know that I'm on the right-hand side of my normal curve because I'm looking for the 90th percentile. So I'm looking for more than 50% lying to the left. So it's got to be on the right-hand side, meaning a positive value of z. So that helps me narrow down whether I'm looking for a positive z or a negative z. Then, once I figure that out, I'm going to look for the closest value that I can come for the area under the curve being as close as I can to 0.9000. That's the 90th percentile. So, as I look through here, I'm just trying to see, I'm getting closer with this one right here. That's 0.92. So that's about in the 92nd percentile. Here's 0.9066. And then if you look, this is the closest I can get right here. If I look at 0.8997, that is super close to 0.9. Okay, so that would be 1.2. And then if I come up here to look for my hundredths place, it would be 1.28. So my value of z would be 1.28. Okay, now that we know the value of z, we know that it's 1.28. We're going to use our formula to work backwards to find our corresponding value of x. So remember we had this formula where we find z by taking x minus the mean over the standard deviation. And then there was another example where we had to work backwards and we found x by taking z times the standard deviation and then we add the mean. Well, because we're looking for x now and we know what z is, we're going to use the formula in reverse, which is this one right here. So I'm going to find x by taking z, which we found from the table is 1.28. I'm going to multiply it by our standard deviation, which is 5, and then add our mean, which is 63. When we do that, we get 69.4. So what does this mean again? Remember, the question asked to find the 90th percentile. So the 90th percentile means if someone gets a score of 69.4, then they're in the 90th percentile, meaning they scored higher than 90% of everybody else. And then only 10% scored higher than they did. So now let me show you how you can additionally do this using the calculator. So now using the calculator, rather than using the table, it's just another way to do it. I'm going to go to the distribution list again. I'm going to hit second bars. And I'm going to use this option right here that says option number 3, inverse norm. I'm going to hit enter. I'm going to put in the area to the left, which is basically the percentile. So I'm going to put 0.90. I'm going to put in my mean, which is 63, and my standard deviation is 5. Now we're looking at the area to the left. This is the 90th percentile, so I want 90% to be to the left. So I'm going to make sure that that says left. And then I'm going to put paste, and I'm going to hit enter. And it's going to give me the same value, well, not the same, but pretty darn close to what we had before when we did it by hand using the tables. So we got previously 69.4 using the tables. This is giving me 69.4077. So it's going to be slightly different because the table is just an approximation. If you remember, we weren't able to find the exact percentage of 90. We got really close. We got like 0.8997 or something like that. But we weren't able to find 0.9 exactly. And that's why this is off just a little bit. But it should be close enough that you can get the right answer. In the last part, we're going to find the 70th percentile. So we're going to use the same methods as we did in part C. I'm not going to go through both methods again. I'm just going to use the calculator method, but feel free to practice using the table and the calculator method. If we want to find the 70th percentile, that means I want to find the value of x that makes it so 70% of the data is to the left and 30% is to the right. So I'm going to put in on my calculator using the inverse norm. The first value that you put in is the percentile. So I'm going to put in 0.7 or 0.70, whichever you prefer. Then the next value you put in is your mean. In this case, 663. Then you put in your standard deviation, which is 5. If you have the option, some calculators that are newer has that option where you can say that it's to the left, the center, or to the right. So make sure if you have that option, you pick the left. If you have an older model that doesn't give you that option, then by default, it's always going to be to the left. So if you don't have that option, don't worry about it. It's by default to the left anyways. When you hit enter, you should get 65.6. So the value of x that gives us that cutoff is 65.5. So that means if I was a student that got an exam score of 65.5, I would have done better than 70% of everybody else, and there would have been about 30% that did better than me. Okay, in this next example, we have a personal computer is used for office work, at home research, communication, and it goes on to list a whole bunch of things that it's used for. And then it says, suppose that the average number of hours that the personal computer is used for entertainment is 2 hours a day. It also says, assume that the times for entertainment are normally distributed and the standard deviation is half an hour. So we have a normal distribution. I'm going to practice using our notation here. This means the variable x is what we're going to use, and n stands for the fact that we're using the normal distribution. Then we're going to put our mean in here and our standard deviation. Now, if we look at the picture, We have our normal curve here. Our mean is in the center. The question wants to know what's the probability that a person uses it between 1.8 and 2.75 hours a day. Well, 1.8 would be a little bit before 2, so about right here. 2.75 would be about right here. And we want to find the probability of the time that they use it per day falls between those two times. So we're looking for that shaded area under the graph. Now you can use the tables for this. My preference is to use the calculator. Since I walked you through how to use the tables in the previous example and all those different parts, I'm going to now stick to just using the calculator method. But feel free to use the tables if you'd like. Just make sure it checks out with my answer. So the probability notation for this is going to look like this. We want to find the probability that x, which is our variable, is between 1.8 and 2.75. That's the number of hours that someone uses the computer for entertainment purposes. So if we want to use a calculator for this, we're going to use the normal CDF. We're going to go to the distribution menu on our calculator and find normal CDF. We're going to first put in the lower limit, then we put in the upper limit, then we put in our mean and our standard deviation. So in this case, my lower limit is 1.8, my upper limit is 2.75, and then my mean is 2, and my standard deviation, which was given to us in the problem, is 0.5. Now, when I put all that information on the calculator and I hit enter, that is going to give me a probability of 0.5886. So that means that the probability that a household personal computer is used between 1.8 and 2.75 hours a day is, and that's for entertainment purposes, is approximately 0.5886. Now for part B, it says find the maximum number of hours per day that the bottom quartile of household uses a personal computer for entertainment. Well, the bottom quartile would be the smallest 25%. So when we look at the smallest 25%, I want to figure out what that value is. So I'm looking for the value that gives me that cutoff point so that you have the smallest 25%. So I'm working in reverse here. I'm trying to find this value, knowing that I want 25% to lie to the left. When you're working in reverse and you're trying to find the percentile, remember we have that calculator function, inverse norm. So on the calculator, I'm going to put inverse norm. I want my percentile to be 0.25. Remember, this should be the percentile. Then the next thing that you put in is your mean. In this case, it's 2. And then the next thing you put in is your standard deviation, which is 0.5. And that will give you the information you need to figure out that value for x. It says the value of x when I hit enter is 1.66. So this right here, 1.66, tells me the cutoff point for the lowest 25%. So that means that the maximum number of hours per day that will be in the bottom quartile of households that uses a personal computer for entertainment is 1.66 hours. If you forget that inverse norm is under the distribution list, when you hit second and then vars on your calculator. Okay, in the next example, it says in the United States, the ages 13 to 55 and up of smartphone users approximately follow a normal distribution, and the mean and standard deviation is 36.9 and 13.9 years respectively. So in part A, we want to find the probability that when we pick someone in this age range, they're between 23 and 64.7 years old. So if we look at our picture, our mean is in the center, which is 36.9. We want to find the probability that the person that we randomly pick is between 23 and 64.7 years old. Using the calculator, we're going to use the normal CDF function, and you'll always put in the lower limit, then the upper limit, then the mean, and the standard deviation. So for us, when we put this in on the calculator, we're going to put in our lower limit, which is 23. Upper limit is 64.7. The mean is 36.9, and the standard deviation is 13.9. When we hit enter, we're going to get 0.8166. So the probability that we pick someone between 23 and 64.7 years old is approximately 0.8166, or about 82%. Looking at part B, it says determine the probability that a randomly selected smartphone user is at most 50.8 years old. At most means we want that to be the highest value. So we're looking for this probability here. Now remember, when we're putting in our upper and lower bounds, if we're dealing with infinities, we always use 1e99, or if it's minus infinity, we use negative 1e99 on the calculator. I want to check to see if I'm below 50.8. I'm looking for this probability. So we're going to use the normal CDF function. I'm going to put in my lower limit, which is minus 1e99. Upper limit, which is the highest value that we want, is 50.8. Then my mean is 36.9, and the standard deviation is 13.9. When you put that in on the calculator, you're going to get 0.8413. Okay, part C. Find the 80th percentile of this distribution and interpret it in a complete sentence. Okay, so the 80th percentile means I want to find the value of X so that this cutoff point right here gives me 80% of the data to the left. So when you're working backwards and you're trying to find the percentile of a normal distribution, you want to use the function on your calculator, inverse norm. And you want to put in your percentile. Then you want to put in your mean and standard deviation. In our case, we're going to put the percentile is 80%, which is 0.8. Then we're going to put in 36.9 for the mean and 13.9 for the standard deviation. When we do that, we're going to get 48.6. So this value here that makes the cutoff point so that everything to the left is 80%, that value is 48.6. So now as far as interpreting it, we could say that 80% of cell phone users, and then that's specifically for the age range of 13 to 55. We would say 80% are 48.6 years old or younger. In the next example, we're talking about the smartphone users again, and we have the same mean and the same standard deviation. The mean is 36.9 years old, and the standard deviation is 13.9. And then we're going to use this information to answer more questions. So in part A, it says calculate the interquartile range. So in order to calculate the interquartile range, we have to find the value of Q3 and subtract Q1. Now we know that Q3 is the 75th percentile, and we know that Q1 is the 25th percentile. So we're just going to use the inverse norm on our calculator to find those values. So for Q3, we're going to find the inverse norm by putting in our percentile of 0.75, our mean, which is 36.9, and our standard deviation, which is 13.9. When we do that and we hit enter, we're going to get that our 75th percentile, or our Q3, is 46.2754. Now we're going to do the same thing for Q1, but now we need to find the 25th percentile for Q1, so I'm just going to put in 0.25, and everything else stays the same. Now when we do that on the calculator and we hit enter, we're going to get that the 25th percentile is 27.5246. So now that we have our Q3 and our Q1, we can find our interquartile range. So I'm going to take 46.2754, and I'm going to subtract 27.5246. When I do that, that gives me 18.8. So the range of our middle 50% of values is 18.8. In part B, it says 40% of the smartphone users from 13 to 55 are at least what age? So at least what age makes this a little bit tricky, because when we think about what at least means, that means the minimum. So we want it to be at that age or greater. So really what we're trying to find is the probability of X being greater than or equal to some number, that this is what we're going to try to find. And that gives us a probability of 40%. But remember, when we put it in the calculator, the percentiles are represented by the values or the percentage that is to the left. So we need to retranslate this in a way so that we can enter it in on the calculator. When we look at our graph, if we want to find that value of X, I'm just labeling it generically as N right now. We want to find that value of X that gives us a cutoff point so that this is 40%. But if that's the case, then we know that what lies to the left is 60%. So when we reword this, I want to find the value of N so that when I look to the left or less than, I get 60%. So this is how we're looking at it in terms of being able to put it in on the calculator. So when I put my information in on the calculator to find inverse norm, I want to find the value for the 60th percentile. Even though we're looking for the 40% cutoff, so 40% is higher, we got to put it in so that it's 60th percentile because we want 60% to the left. So I'm going to put in inverse norm, 0.60, and then our mean, which is 36.9, and then our standard deviation, which is 13.9. And when we do that, we're going to get 40.4215. So that tells me that 40% of the smartphone users And don't forget, it's in the age group from 13 to 55, are at least 40.4 years old. And that's if we round it to 1 decimal place. And the other way that we can say that is 60% of the smartphone users is younger than 40.4 years old. All right, last example of the section. We have a citrus farmer who grows mandarin oranges, finds that the diameters of mandarin oranges harvested from his farm follow a normal distribution and has a mean diameter of 585 centimeters and a standard deviation of 0.24 centimeters. We want to find the probability that a randomly selected mandarin orange from this farm has a diameter larger than 6 centimeters. We're going to sketch the graph. All right, so here is our graph. We have the mean, which is 5.85, and this is our centimeters for the diameter, and our standard deviation is 0.24. And again, this is centimeters. So we want to find the probability that if we pick a random orange, that we're going to get a diameter bigger than 6. This is the probability that we're trying to find. So over here somewhere, a little bit bigger than 5.85, we have 6, and we want to find this probability that it's bigger. So we need to find that percentage that falls under that curve to find that probability. So we're going to use our normal CDF. Now, for this case, we are going from 6 and up to positive infinity. So our lower bound is going to be 6. Our upper bound is going to be 1E99. And that's because we're going in the positive direction. We want to make sure it's positive 1E99 to positive infinity. And then we have our mean, which is 5.85. And our standard deviation, which is 0.24. Okay, so when we put that in on the calculator, we should get 0.2660. So the probability of selecting a mandarin orange that has a diameter larger than 6 centimeters is about 26.6%. Okay, part B says, we want to find the middle 20% of mandarin oranges from this farm, and we want to find what two values those fall between. So this is what we're trying to do. We want to find the middle 20%. So if this is the mean, which we said was 5.85, we want to find the two values so that in here, that center portion is 20%. Okay, so what this means, if I fill out the rest of this graph and look at the percentages, this percentage would have to be 40%, and this percentage would have to be 40%, and that's because the total under the graph has got to be 100. So if I take 100 minus 20, that gives me 80% is in total in those two orange areas on each side. So then when I take 80% and split it in two to see what's in each orange piece, that's 40%. So I can find this X value by finding the 40th percentile, and then I can find this X value by finding the 60th percentile, because from here over would be 60%. So I'm going to do inverse norm of the 40th percentile, and our mean is 5.85, and our standard deviation is 0.24. When we do that, we get 5.79 centimeters. Now I'm going to find the other x value. So this right here is 5.79 centimeters. So now I'm going to find the 60th percentile using the same strategy. Now, when I put in for the 60th percentile and I find that on the calculator, that's going to give me 5.91. So this value right here for x is 5.91. So the middle 20% of mandarin oranges that have that, the diameter is in the middle 20% is going to lie between 5.79 centimeters and 5.91 centimeters. Okay, part C. It says find the 90th percentile for the diameters of the mandarin oranges and interpret it in a complete sentence. 90th percentile means I want to find the cutoff point so that 90% of the mandarin oranges that have that diameter size is to the left of that cutoff point. So I want to find the inverse norm. And I'm going to put in for the percentile 90th percentile, so 0.9. Then I'm going to put in my mean and my standard deviation. And when I do that, I'm going to get 6.16 centimeters. We would interpret this by saying 90% of mandarin oranges have a diameter that is less than 6.16 centimeters.